Alright, welcome back to Meteorology 101. In this video I'm going to touch on the charts, and we're actually going to go into the models again and look into the upper levels. And a lot has changed with the models. The Gfs model looks like it got an upgrade, supposedly be handling systems a lot better. We'll see over the next couple weeks, especially over the weekends. We're looking at the next couple of days, some possible severe weather down into Arkansas, possibly eastern Texas. It's all pretty much right in that area, and then pretty much through Tornado Alley there, and then through the weekend. Next weekend, we're looking at some major short waves moving through, long wave troughs out of the jet stream, some low pressure systems. Almost looks like a cutoff low over the eastern United States, which is like never happens, but usually you'll get a cutoff low over the Four Corners area, and then that low will just sit there until it fills in. Now, once we get into the models, we'll look at this 500 millibar. You'll see a long wave trough get overshot and then leave a low pressure system over the eastern United States, but it continues to follow that path with the jet stream, so it kicks off. It doesn't stay stationary. So let's go ahead and get some surface data on this chart, see what we got for pressure systems. We've been covering these in the last few videos, so we should be pretty familiar with these by now and tracking these systems, what's happening here. So we did have a low pressure system troughing up all the way up into Illinois earlier. Now we got the ridge is pretty much overtaking that area. We still have that low pressure system over Montana, and that one was pretty much being blocked by this high as a high dropped south. So this high pretty much caused a lot of clearing over the Ohio Valley, over Ohio, Indiana, and the tri-state area down in Kentucky. And then we'll see what's happening with that. That's going to have to weaken to allow this low pressure system to continue to the east. I'm going to throw the isotherms on here. I just like to do that on the surface. None of your weather stations do that, but I like to analyze that temperature so we can see where our thermal advection is. It gets a little bit cluttered, but at least we can see what a thermal advection is. We can try to place these fronts, and let's put some surface data on here, all the surface plots. Okay, I'm just running a little bit slow right now, doing a lot of things at once. So, all right, if we look at this low pressure system, we know wind circulates counterclockwise around a low, so we're going to go this way. We have thermal advection all through here. So there's your warm sector, leading edge of that air mass, maybe a cold front, or a warm front out of that, dropping to the south as is being blocked by that high. And then if we had a cold front, it's going to be pretty tough to tell over here because we are in that right around that continental divide. We're on the lee side of the mountains, so trying to pick out a cold front, and I don't see much thermal advection. We got most of our thermal advection there, so you'd almost have to pull that back. See if we got a wind shift there, because we're going to want our wind to push against the front. This is kind of out of the ordinary. That's a 5-knot wind. Probably just variable in that area since it's toward the center of that low. Trying to get too cluttered here. I don't think it's going to let me undo a lot of that, so I'll have to clear it out. Alright, so warm front. Looks like a wind shift in this area. Not much here because we're in the center of the low, so it's hard to tell. But if we had to, we could pull that cold front to the west. Looks like a wind shift here, so we do have a little bit of troughing in that area. We do have this low pressure system over Texas. We just still have that easterly flow, so we can call that closed off right there. And with the isotherms being pretty weak, you're pretty much troughing in this area. The isotherms are there, but the isobars are weak. We don't have really any pressure gradient to move those isotherms. So if we had any advection in that area, it'd be very slight warm air advection. We do see the marginal VFR, the IFR conditions with the red, and then we do have that southerly flow, so we do have a little bit of thermal ridging in that area also. So this is the area we're going to be watching for that severe weather in the next couple of days. I'm going to go ahead and erase that again. Now 51 for the dew point, 50, 43. This is a late chart, so our dew points dropped for the evening. We're 64 to the south. Looks like 68. So higher dew points are way well to the south. And then looks like mostly in the 50s in Arkansas, Oklahoma. But those could pick back up. As the temperatures rise, the dew point rises, then we could get this whole area where the SPC has that potential for thunderstorms and possible severe weather in that area. So let me see if I can pull that chart real quick. Turn off the ink here. There's the latest chart for the SPC. So we had most of our dew points are well to the south, but we are going to pick up, like I said, and looks like Arkansas, eastern Tennessee, western Tennessee, northern Mississippi. Looks like that's going to be the strongest part for possible severe weather. It's a slight chance for thunderstorms and then isolated severe weather. So we'll get, once we get into the models, we'll see that it looks like that low pressure system possibly moves out, and there's we got to have something there to cause our lift in that area. So we're gonna have to have frontal passage or something go on right there to give us that risk. You can't just have dew points and then nothing to cause a lift. You have to have moisture, instability, and lift. So we have the moisture with the 50, 60 dew points. We have instability with that low pressure system that's over Texas. Now we just need something to give us the lift to trigger this thing and give us our storms. So, all right, let's throw our computer generated fronts on here. This is going to be a mess, I know it. So alright, so with the fronts on here, this thing gets pretty cluttered. So we just kind of cipher through all this stuff. Let's see. As far as this low pressure system, it does have that front, the warm front, right along where we were saying with that head of that warm air. And then it's kind of doesn't know what it's doing on the lee side of the mountains with that stationary front right there. So we're going to keep our cold front stretching to the west, because we pretty much proved that with the wind shift. Plateau high, some troughing, and then there's that low over Texas. I would say get rid of all that mess. So right now we got, I see an easterly flow right there, so I'm going to call that low accurate. This warm front, ignore that. Maybe if you had anything, you'd have a little bit of warm air advection out of that low with the southerly flow. Troughing behind that. That's all lee side of the mountain, so you could have troughing pretty much just from adiabatic warming. You get the winds rushing down the mountains, compressing that air and causing it to warm and creating lee side troughs. This, not sure what they're trying to do there. Maybe a low wanting to form up there. Let's get back out of that mess. We got calm winds. Don't really see any easterly flow. I see a south easterly. I'd have to clear that out and just put the data on to justify that low, but I think what they're doing is just with the high pressure to the south, high to the north, just running a stationary boundary just to separate these two highs, because you got winds going clockwise around the high, winds going clockwise around the high. So now the only way you can have two winds opposing each other like that is to have some sort of boundary between that to make it make sense. So that happens on a stationary front. Winds oppose each other and the boundary separates them. So I think that's what they're doing there. We'll keep it on this low in the models. This thing just been kind of moving around. This low pressure system should push a little bit to the south. We talked about that earlier, following that jet stream that was coming down with that long wave trough over the eastern United States. So that's going to be pushing, still continue to push to the east, this trough, and then we have that low pressure system going to drop a little bit to the south and then push back up. That's what I would suspect to happen with that. So we'll keep an eye on that. And then, but that only depends on this high pressure system. It's going to have to get out of the way because that low can't move it. That's why this warm air advection is just going to be blocking this warm front. Will just drop south, and it could go into that low, but we'll have to see what happens there. But the push it against this high, that, like I said, that it has to drop south. This high has to get out of the way. So that should be continue to push east, allow this low to push east, and then it drops just a little bit south and then moves over. So for the weekend, I think we're expecting some rain tomorrow. Let's maybe with the instability in the Great Lakes region, get some rain in that area. So, all right, let's get out of this. For the surface, that's pretty messy. We can just throw the plots on here real quick. Let's just see if that low is over there down by South Carolina. All right, if we look at this data, we can see northeasterly, northerly to northwest. So we could have a little bit of rotation right here. Calm winds there. Everything else around this is calm. Well, we could have a little bit of rotation there, so we'll have to keep an eye on that low. Let's throw our fronts on, and let's see what we have for that low. Okay, so move that low a little bit to the east, and I think we might be in business on that. With that stationary front, upper level divergence, given that support, we could have a low form up over that stationary front. So, all right, let's go up 850. I'm going to do let the computer generate this chart. What I'll do is try to get some more data on here as far as the station plots, because we got upper air data now, so it's a lot thinner than the surface. Alright, so get rid of that. Alright, we can pretty much stretch this moisture all the way back around through here, because we got dew point depressions of 5 or less, so we can close all that off for moisture. Close all this off for moisture. So we have pretty significant moisture in that area, right where we need it for that severe weather that they're looking for in the next couple of days. Alright, so ridging, troughing, ridging, troughing. So we just got This is going to be a major short wave right here because we have all this thermal advection. Winds are going pretty much northerly. What do we got going on here? Thermal ridge. Got this red, and it's not blending well with the red, so it's blending too well with the red. So there's the thermal ridge all the way around that one. Thermal advection here. That was our warm air advection, so it looks like we have significant warm air advection up there too. So at the 5,000 feet, 850 millibar chart. So you can almost place an upper level. Get the right color on this upper level front there. We do have this cold air advection here. So if we had to come out of that low, come back, maybe have some have an upper level front right there. So good, strong, major shortwave supporting that low pressure system. Now, and then that high pressure system, we do have that ridge supporting that high that was over the Great Lakes region. Moisture, significant moisture in the south, supporting that low and supporting the SPC as far as that warning area. So that's pretty much it for that chart. Let's go up to 700. Alright, let's just draw this out. We're going to see a lot more moisture on this chart too, I think, more than what it says. This algorithm set for anything at 60% humidity or higher. The upper level charts, anytime you get a dew point depression of 5 or less, the difference between the temperature and dew point of only 5 degrees or less, then you have significant moisture at that level. So we can still say we got significant moisture pretty much all the way through there and all the way down here. So we still got, with that onshore flow, we still got the significant moisture up to almost 10,000 feet. So we have this low pressure system. We don't really see anything there on the upper levels. We've got ridging in the upper levels at this chart, and then troughing to the east, ridging, and then we have that major short wave. We still got a significant major short wave right there. You can see those isotherms crossing the contours, thermal ridging right through there, and then pretty much cold air advection all through that area. So as the winds push down, colder air pushes into warm, so we got thermal, that cold air advection, and that's a major short wave. So we have the troughing, and it's a baroclinic trough, so we have a major short wave, still upper level support for that low. Pretty strong ridge. We do have a baroclinicity going on here, and that is upper level support for that high. And all this moisture, that's that low pressure system moving off to the northeast. So this pushes through. We will see some snowfall over the Great Lakes region and all the way to the northeast. I think they're going to get the significant impact of the snow at this time. So what we're going to keep on the next couple of days is more or less this low and that upper level trough support. All this stuff pushes to the southeast, and see what's happening down in that warning area that the SPC has issued. So we'll get to the models as soon as these charts are finished here. Let's get up to 500 millibars. Now we're going up to 18,000 feet. let this draw out. And our moisture, I mean, it should continue all the way through. All the way through where we've seen it. Especially with that jet stream. We can pretty much see that jet stream's right through here. So, even probably right down through here. Here's your strongest contours. So, there's the jet stream. Still upper level moisture all through here. Just close all that off. And still got some upper level moisture over Arkansas. A little bit down in the southern New Mexico, Arizona, and down into Mexico itself. So, alright. Still do have some thermal advection in the upper levels. So we still have that support there. The trough is a little bit weaker. Get rid of that. Pushing down through there. Some weaker thermal advection, but it is there. So we do still have upper level support for that low. We don't have any closed low pressure systems or anything like that, but there's still a pretty good low right there. And then also with this ridge, some weak thermal advection with that ridging supporting that high pressure system. So we got, you know, pretty good system right here happening, that as long as that high moves out of the way, lets this low come through, we'll drop south a little bit and then come back over the Great Lakes region is that clipper. And then significant moisture over Arkansas. So in our warning area, we still got moisture all the way up to 18,000 feet. So, you know, we're still pushing pretty good for, you know, you get some severe weather. You got the moisture in the upper levels start creating that hail, thunderstorms, and you know, probably getting something in Arkansas. I would look through that region right through there for our tightest point for severe weather. All right, so let's go pull the jet stream. I'm going to do this one manually because of the colors I got set up and everything. I don't have an algorithm for that. We have a jet finger here, jet finger to in the southeast, pretty much a long wave trough. Hold on just a second, I'm still at 500. I got to go to 300 millibar. That's a 500 millibar jet right there. So we'll see. We should see a significant difference now. Up to 30,000 feet. We just jumped from 18,000 to 30,000 feet. So you can still see significant winds showing up on the 500 millibar chart too, with that long wave trough and supporting these systems. All right, so we got a jet max dropping down out of that ridge into this trough. So that would weaken the ridge, strengthen the trough, but you got a jet max over the northwest that's pushing in too, so that could definitely deepen that trough right there. Let's get our pressure on here. Our temperature, isotherms, and then we'll do the station plots. We look at our strongest winds right here. Like I said, going through our jet max, dropping down into that jet max, dropping well to the south, and then through that jet max. So we got that low to the north. Now we're getting the isotherms becoming more parallel to the contours. I'm still crossing right there, still crossing here, so we still have thermal advection in that area. And then thermal advection, weak thermal advection maybe in this area, still supporting that low that's on the surface and that high pressure system. So we still have pretty good upper level support. Now our moisture doesn't draw moisture on this chart, but if we were to put moisture on here, right through there, right through here, right there. Let's see, just say right through here. This is, that's an M for missing, I think, right there. So that wouldn't know. So we can go pretty much moisture all in that area, and then dropping all the way to the south for upper level moisture too. So, all right, we're still have moisture over Arkansas, 30,000 feet. We have all this moisture down over Texas. Texas was in the thunderstorm area. I think Arkansas was pretty much in the middle of the enhanced area or the moderate area. So clear this out. Let's go back on. I'm clicking too fast here. Erase that. Alright, so let's go. Okay, slight marginal. I'll get you back on here. Slight marginal, and then just thunderstorms area. So like I said, Texas, they're in the marginal area. The slight risk was through Arkansas up into western Tennessee. So Arkansas, I think right there, maybe a little bit north, I think right there is going to be our most significant area for anything that might be severe. So let's go over to the models. And let's see what kind of what these systems are going to do. Get an idea. Use that as our tool. Find out where I'm going here. All right, here's the surface. All right, I don't want to jump too fast. All right, so we have still have our low to the north, warm front, there's the high, southern Minnesota. This is showing that low pressure system over South Carolina. Like I said, we could push that east a little bit. We had that stationary front pushing through. Then we had that low pressure system over Texas. This has one closed isobar right there. So that's that low pressure that's been just hanging out there for a few days. Leading edge of this air mass. A couple of days ago we had a double front. So we had a cool front and a cold front. And then that kind of went up. And then the charts had a stationary front right up through here along the lee side of the mountains, but I think I was just picking up a trough. And then so if we brought these fronts into this low as a little bit of warm air advection, and then on the back of that had a little bit of cold air advection, then it would just be stationary. There wouldn't be anything along the mountain range tying into that one, but this one could come back and tie into that warm front, and then this could just be another front that's further to the north. But we'll have to see what's going on there. We didn't really show a double front this time. That's just what we showed a couple days ago. So if anything, that front's probably pushed off, maybe became stationary, and then got into that low, because we're on the leading edge of this high pressure system, and that should be pushing to the south following that jet stream. And then looks like the here's that other low pressure system to the north. So possibly would be more of like an occlusion, and then coming into the cold front right through here. So we got quite a bit of moisture associated, a little bit of moisture associated with that. So this one should be able to push off to the east. And then this high pressure system pushing to the southeast, allowing this low pressure system to push east. Like I said, this probably drop a little bit south and then push back around and follow that low out. Alright, so let's go and see what happens. So that low pressure system just pushes pretty much directly east, along with that high pressure system. The high drops to the south and starts pushing east. The low pressure system just kind of just hangs out, drops east, and then it looks like another high pressure system coming down behind that. And there's our frontal boundary. This is for the 612Z. It'll be like 6 or 7 a.m., 6 a.m. Central, 7 a.m. Eastern. So let's go. I want to pull that over. Let me get back to where we were. I'll go the other way. Let me see. Alright, right there I think is where we were. Okay. That's pretty much where it's developed. There's the line. And then it has another low pressure system over northern Louisiana. Alright, so it's got a low there. There's that low, move to the east. Here's the high. So the cold air mass originating all the way down into Texas. Pretty much cold air advection all the way through here, right behind that front. So we got, I'll need that. Let's go a frontal boundary right through here. Looks like the strongest part of the convection is right in that area. Low pressure system over northern Louisiana, and then we were saying Arkansas had the most moisture all the way up into the upper levels. This is pushed further south into Louisiana, Mississippi, and then all the way up into the Ohio Valley, pretty much following that front. But I would say anything we'd have to get into the stability charts, severe weather, HRRR, get more detailed stuff on this, find out exactly where this is going to show up. But it looks like northern Louisiana, even possibly I'd say up in Arkansas, just because of that moisture. Once that moisture is pushing east, if we get something that advects that moisture over and then into western Tennessee, so we'll keep an eye on that. Pretty much here on the models with it now. Let's go with keep going forward and push that. Most of that convection pushes south and through Mississippi and then Alabama. And once that frontal system hits the mountain range, it just pretty much rains itself out and then breaks up. And that low pressure system moves to well to the northeast. It looks like a lee side low over Colorado, dropping south down into Texas. Pretty much following where that other low pressure system's been moving around there. Path of least resistance, and then that's just, we get another low, just kind of pops up over Georgia. And this is for December 8th. So it looks like some possible snowfall into the Ohio Valley region with some mixture snowfall to the 8th, about 12Z on Wednesday. I would say if we got anything off of that, we don't have a real significant system associated with this, but this is just like a major shortwave moving through. So I would say, as warm as it's been, wouldn't expect a whole lot of accumulation from that. And then most of your snow, the heavier stuff starts moving up through Pennsylvania, New York, and then into Vermont and New Hampshire, Maine. I would say that's where you're going to get most of your snowfall. That's going to be pretty significant accumulation. Pretty much right in that area right there. We may see some snowfall in Ohio, but we're not going to get, I don't think we're going to get inches of snow. We're just going to, I don't even know if we'll see a dusting. Like it has been pretty warm here. I think the ground's way too warm. It's going to melt as soon as it hits the ground. So just based off these charts, if these charts are right for moisture, we'll have to, as Wednesday approaches, we'll have to see what we're actually going to, see what changes on these models if we're going to actually get any accumulation from that. Alright, so now we're going into Thursday. That low pressure system moves off. Still snowfall up in the northeast, so like I said, they're going to get some accumulation up there. I'm not set up right now to pull the accumulation charts to see what kind of snowfall we're going to get, but now we end up with another, looks like another trough to the north, central U.S., moving through Wisconsin all the way down into Iowa. Looks like some snowfall, Minnesota, Wisconsin, and then through the Great Lakes. Now another Colorado low, kicking out of this, at least out of the mountains. Now this thing looks pretty intense all of a sudden. So over Colorado's closing up. It's got some pretty strong intensity to it. Maybe some upslope on the northern part of that low, and then causes some snowfall in Colorado, Denver. Some pretty heavy snow through Nebraska. We actually got a couple pieces of purple there through Nebraska and Iowa, and then dropping some snow, significant snowfall through Iowa, Wisconsin, and pushing up into the Great Lakes region. Alright, so our green moisture, anything that's rain, looks like another frontal system pushing through. Maybe a little bit of heavier rain over the Cincinnati, and then pushing to the east through Portsmouth and into West Virginia, into the mountains, and does the same thing. It rains itself out over the mountains and pretty much dies out. Now over the Great Lakes region, continues getting some significant snowfall. Northern Michigan, push to the northeast, mixture over New York, a little bit of mixture through Vermont, New Hampshire, snowfall in Maine. They're getting the most of the hit for this snowfall, so they're going to continue getting some accumulation in that area. So now we have another disturbance to the south. Let's go back. Kind of just sitting there over New Mexico. Looks like a shortwave moves through out of the Four Corners, picks up that low, and then kicks out right over Mississippi. Looks like it becomes a low, so some significant rainfall through Arkansas, and then it's even got snow all the way down and almost into the panhandle of Texas, Oklahoma, mixture and snow, and then pushing off with some significant rainfall, maybe some convection or even severe weather if a low pressure system develops off that frontal system going through the southeast. And then that shoots off to the northeast, and then we get maybe a little bit of light snow up into all the way from Cincinnati to Columbus. Some convection all to the south of that through Kentucky, West Virginia. And then that low pressure pushing off to the east coast. And then looks like snow all the way into northern Virginia, Maryland. And then that low pressure system taking off. Another high dropping down to the south, clearing everything out. Now this is on, all this is taking place, a second low right there kicking off. That's the weekend of the 11th. Pushing up into Ohio. Pretty significant snowfall right there over Ohio. So let's see. Here's our rain snow line. Let's see where we are on this 540. That's like a 546 line. The 540 line actually looks like it's even further north. But we still got snowfall in that area. So the 540 line's a tool. We'd have to pull other charts, see what height levels we got to determine exactly where we're going to have mixture. Because pretty much Cincinnati's right on the line. To the north of that, Dayton, Troy, Sydney. That looks like maybe some accumulating snow up in that area, just because of how heavy that is. So when we have that last high pressure system push through, jumping all over here. Let's go back. looking for that high, we should have some pretty cool temperatures. We'd have to look at a temp chart. This is going to be low pressure. The high kind of hangs out over Iowa, and then this other low, that high just weakens and then allows this low to push. It keeps it to the south, but it allows it to push east, and that'd be the actually wraparound moisture from that low pressure system pushing over that high pressure system. Now we're getting into the cold air. But so let's go. Let's get back. Alright, so like I said, we're in the, okay, that pushes past. Now here's the high pressure system. So right through there. Now that's that cold air. So now that cold air was getting that wraparound, and that would be dropping through the cold air mass to give us the snowfall. Alright, so let me clear this out. Erase that. And I just jumped back everywhere. Let's see, we're all over the place now. Let's go, alright, there's where we were. Now, like I said, that low pressure pushes off, the high pressure pushes in to the east coast. Now, looks like the northwest is getting hit with a lot of moisture there again. Snowfall in the upper elevations. The atmospheric river picking back up and just pumping that through the northwest. Alright, so let's not miss this low pressure system coming through. Another one out of Colorado, pushing to the northeast. Looks like mostly rainfall. And this is for the 17th. Another Friday, looks like another weekend possibly. Being wet, and then maybe even some light flurries wrapping around that low on an 18Z on the on that Friday. So Friday evening, Friday afternoon. So, and then that low pushes up. Now it looks like the northeast getting clobbered once again. Rain, possible heavy rain, and then some snow through Pennsylvania, New York. And then as the low pressure pushes off, it looks like a lot of the moisture dies out, but it looks like they get hit with some, Maine gets hit with some, maybe some icing mixture up in that area. And then that low pushes off and high pressure dominates the southeast once again. And then it had another low pressure system back there, Colorado again. And then that's pretty much where it dies off. So this is where the model's in. This is pretty far out. I mean, this is 384 hours out there. Now, what we end up with is right there, you can see that closed isobar with a low. High pressure system moves in. So it looks like polar outbreak. We're pretty much, we're running, you know, Colorado lows. There's Colorado right there. Utah. Low pressure system after low pressure system just getting kicked out of here. So let's go into the upper levels on these models a little bit, and let's see what their upper level support looks like. Like we said, we had that low pressure system over Montana, and we pretty much had, you know, that major shortwave to the north supporting that all the way up to 30,000 feet. So let's go up a few levels here. Find out where we are. Here's 500 millibars, 18,000 feet. There's our jet stream, pretty much east to west, west to east. Let me get my draw tool here. Make sure you guys are on. All right. So there's our jet. Pretty smooth at this time. Nothing significant. We do got a little bit of troughing there. What's going on now? Get that back up. Okay, so let's go through this. We're talking about pretty much every weekend. There's a deep trough down in the south. That's almost like a cutoff low. In the upper levels, that'd be red anyway, but possibly a cutoff low. That's why we're so smooth on this jet in the north, because this jet was once dropping down a long wave trough, coming back, and then it couldn't make that curve, so it just overshot itself and became a finger to the north. And then this is just these two fingers right here wrap around that low and just sits there. So that typically happens a little bit further north over the Four Corners region, but it can happen that far south. That's a pretty deep trough. Usually don't see them that deep. But what we look for is to the west, if you have another major shortwave with the advection come through, kick this out, and then that could kick it out to the northeast. And if we watch these, we've seen these lows just continuously coming out of Colorado and just push it to the east. So with this upper level low like that, we do got that kind of support for this happening. So let's keep going forward. So that low sits down there as a cutoff low, and that just sits down there in Mexico and just looks like it starts to fill. So then becomes just merged in or dies out. So now we got another long wave trough coming in from the west, but we have that trough over the east coast. That thing just goes down, starts to deepen, pushes over the Great Lake region, and this is into the 7th, 8th, and it's pushed off. So we got some pretty intense jet stream there. Looks like that low pressure system kind of got absorbed into the jet, but another long wave trough pushing through. So we're only at 500 millibars, 18,000 feet on this jet stream. So there's heights and wind. So we're long wave trough. Let me get my ink up here. Ridging and troughing. So this is a pretty deep trough right here too. So and that gets pretty intense all the way to the south right there with that jet max. So this is Wednesday. This is when we're getting that front move through, and we possibly snow in the Ohio Valley region. So pretty much corresponds with that. That was that low pressure system moving off, and then does have jet support with the long wave trough behind it. So that's pretty good there. If it picks up a lot more moisture, we get a lot more snow. But this, like I said, the ground's been pretty warm for Ohio. I don't see a lot of accumulation there. All right, let's go. Trough does deepen over the east coast pretty deep before it moves off. Now another deep long wave trough pushing through. Now this one's pretty intense, almost getting a cutoff low there, but keeps moving east. It hangs on. It doesn't overshoot that one. But that's a pretty deep trough, and this is on the 12th. So we were talking on the 11th. We got jet support. This is pretty intense over the Great Lakes region over Ohio. That's but we got a pretty deep trough over Texas. So I'm surprised that one didn't cut off. Leave a cutoff low back here, but it's just continuing to pull along right there along with it. So just another system pushing through. I mean, that's a real deep trough, and then over the east coast once again deepens. Now we're covered by ridging throughout the U.S. That's one of those high pressure systems in the southeast, and now another long wave trough in the west pushing through. Now that even a deeper trough. I'm surprised there's a cutoff low that continues to push to the northeast, becomes its own system right out of that pretty much a mid-level jet, but that trough deepens deep, and then it finally cuts it off and kicks that low out. That'll be the one to watch for. Let's see, this was on the 18th, so we'll have to see how this one ends up. It's all over land, so it didn't start over the Gulf. If it started over the Gulf or something, I would say it could pick up the moisture it needs to create some major blizzards. But even to the northeast, they've been getting hammered pretty good, so that's a pretty intense system. Usually, like I said, you get the cutoff lows. That's in the southwest, not in the southeast, let alone the mid latitudes. Pretty intense jet wrap around on that too, with just being a 500 millibars. So I'm gonna have to go see what there's where the models end right there. That's that last system to push through. A couple weekends from now, 384 hours. So let's go to the 300 millibar, and once again we pretty much start pretty linear on this jet stream. Got that finger to the south, a cutoff low, that's ridging, this cutoff low right there, and then that jet stream just staying west to east. This is 300 millibars, so we'll see a whole lot more intense winds at this level. But like I said, there's your cutoff low. I mean, over the southwest. I mean, typically, like I said, you'll see them around the four corners. And then this one just kind of meander around a little bit and then fills in. So let's go back and look at let's keep going forward with this. Now there's a trough deepening right through the central US, the north central US, and then pushes to the east. So that supports one system over the 6th. That's over the next couple of days. That's the first system that comes through. We're looking for rain. Now here's the intensity right there. The next couple of days see, that is Tuesday. What are we looking at? Like Sunday. See, Monday. That would be right through there with the jet for Texas, Arkansas. There's a little finger right there. So we got support for any system right there. So at and ahead of a trough would be where any of the weather happens. So that's kind of picks up right there where western Tennessee, northern Mississippi. So right in that area, I would say that would be probably most of your potential for severe weather right there. Alright, so let's go forward. Real deep trough right there. Long wave supporting that next system on the 8th. That's on Wednesday. That's actually the system that pushes through, creates that snow through Ohio. So we do have our support there. Long wave trough. I mean, that's pretty intense. Like I said, that thing picks up more moisture. Could have been a little more intense than what we're looking for in the southwest Ohio, but possibly some significant, maybe some dusting or something up in Columbus. We have to go back to the surface and see where our moisture was. Like I said, we'd have to get into a little bit higher resolution models too to start picking up exactly, look at them snowfall models and how much precip we're looking to fall. I'll pull another chart on my other program and see what the precipitable water is and find out what's the max we could possibly get for snow. But like I said, with the ground being so warm, I wouldn't expect a whole lot of accumulation in Ohio. Pretty deep trough moving through the northeast, the New England states right now, but and then another long wave, another trough coming through, even through Ohio, Pennsylvania. This is out the following weekend. Like I said, the weekends were just getting clobbered for the eastern U.S. Now there's that last deep system. That's probably not even quite there yet. We're only on December 12th. That's a pretty deep trough pushing through, and look for that to almost become a cutoff low, but it didn't, unless it happens over the Atlantic. But pretty strong ridge, another deep trough. I mean, we just got these troughs are just, I mean, these things are massive, continuously just pushing through. I mean, that's a deep trough. I mean, this jet stream shouldn't be able to have the energy to make that turn. It takes a lot of energy to make this turn. So, like I said, typically it's just overshoots and then you get a cutoff low. So, I don't know what hour we're on, the 294. We've got the 384, so we're not there yet. But that's one that cuts off and pushes to the northeast. That's a pretty intense system. I mean, it's far out there, but that's usually you don't see that there. You see that over the Four Corners area. So you'll get that trough come down, jet stream, overshoot, and then you have that low like we did in the southwest. So I don't know, man. That's pretty intense, and that's, you know, if you get a trough that deep, you got to have a jet wrapping around the system with it typically. So let's go. We're pretty much to the end there. That was that one. That does become a cutoff. So, but this also gets kicked out too. It doesn't just become stationary over the East Coast. Which, if that did, that could be pretty nasty. But it does become a cutoff low. It looks like a pretty intense cyclogenesis on that system, so we're gonna have to look at that. Keep an eye on that. That's pretty far out. Maybe these models are just that far off, but with these troughs, it was just a matter of time before one of them did become cut off, because we got some pretty intense troughing going on, like that right there. And, you know, for that to have the energy to make that turn, like I said, I'm surprised all these aren't cut off lows. But there's your jet support. Let's go back to that surface one more time, and then we're at the end right now. Take her back to the beginning. We'll just run through it real fast. Dakotas, Minnesota, all the northern states with that clipper system. And now looks like the high pressure pushing to the south, and then a cold front developing out of that low, stretching all the way down into Mississippi, Arkansas, northern Louisiana. And this is causing, this is Monday, looking through that severe weather. I would say right there through that area would be potential for severe weather with what our dew points were. So high pressure pushing through, low pressure dropping down to the south along the lee side of the mountains, and then across Texas. And then just a low pressure develops all of a sudden up out of Georgia, and then pushes to the northeast. Now significant snowfall through, looks like this is Wednesday. That's where we get that snowfall through Ohio. I mean, we could get pretty much Cincinnati, looks like mostly mixed, maybe some light snow, and then to the north of that, depending on the ground temperatures, man, how much really we're going to get for accumulation. Pennsylvania, the mountainous regions, we're going to get, you know, that mixture, the icing, and then the northeast is just going to get hit with heavy snow, and that could be, now they're looking at several inches up there. I mean, we'd have to get into the models to find out exactly how much. We'll pull up the precipitable water. Our precipitable water would be what we have right now, so it's hard to really judge of what you're going to have, you know, Wednesday into Thursday, off of a chart that's current. But here's a low pressure system out of Colorado, pushes to the northeast. Pretty intense weather in the southeast right there. So I haven't seen too much info on that one yet. That's on that's the 12th, and then some more significant snowfall through even Ohio right there. That could be with them. Let's see what we got with that high pressure. We got high pressure pushing through, cooling us off. I mean, just a matter of getting that ground cold, and then we can get some accumulation. So another significant snowfall right there, and then high pressure staying around for a little bit right there. That could cause all the cooling on the ground that we need, and then the low pressure push through. But that's mostly rain. Snow to the north over Michigan, wrapping around, and then lake effect over New York, then getting into Pennsylvania, northeast Ohio. High pressure once again, cooling everything off, and then that's that low pressure system that ends over the panhandle of Texas. So let's go back just a little. There's that system right there to cut off low on the surface. So this thing cuts off a deep trough, the central US. This is with this thickness chart. Let's get a. Alright, there's a deep trough right there. Jet stream right here supporting that low. Warm front, cold front. I mean, a lot of convection right here possibly, but I'm not too sure about convection because the high pressure system moving in to cool off. They're cooling off this atmosphere. Like I said, once we get to this point, I mean, we're pretty far out, so we'd have to look at some other models and maybe some severe models to determine what that's going to do. But that's a pretty intense system, though. When it gets cut off, the thing is, it just continues to move to the northeast and out of there. I mean, it doesn't cut off and just sit there. And then it looks like another low pressure system. There it is, right there. That the intensity of that. So I'd like to go back, and it looks like some snowfall through Ohio, mostly to the north, all the way to the Ohio Valley, wrapping around all that moisture, and then getting the heavier stuff off the Great Lakes with the lake effect, and then into New York, and then the high pressure dominates, moves up, it comes up to the north a little bit, clears everything out. So I don't know, we'll check that out. Let's go pull a chart real quickly so we can pull up precipitable water. We'll see what kind of especially in the southeast right now, because over Texas, the Gulf states, just because the next day or two looking for that severe weather. Let's just, if we see what our precipitable water is, then we can tell the areas of severe weather also. Alright, let me go. This will generate itself. Make sure I'm on the right level too. Sometimes these charts, when I generate these charts, if I'm on the wrong level, they'll give us wrong readings. So I'm way up in the upper levels right now. I might need to redo this one. Bring it back down to the surface. Pushing up into Texas a little bit, but like I said, that's the upper levels. Let's do this one more time. Looks like the same chart, that height didn't affect it. Most of our water to the south, let's see, 0.7 inches going up in Arkansas, 0.6, half an inch up through northern Arkansas, western Tennessee. That's just pretty much, like I said, the severe weather, that weather outlook is, SPC has that the next, I think it's day 2, so could possibly be tomorrow, possibly Monday. This moving to the east and then being up to, if this pushes up 3/4 of an inch of rain or 1 inch of rain. I mean, anytime you get severe, you can pretty much almost double this. It's like a blizzard. You know, if you get a blizzard, like up in the Northeast, that heavy snow they were looking to get, you know, you can take, so 1 inch of rain is 10 inches of snow. So, you know, if they're getting half an inch of rain up there, then they're going to get 5 inches of snow. But if it's a blizzard, then you double that. It's 20 to 1. So then they'll get 10 inches of snow off of a half inch of rain. You know, just because blizzard conditions is a lot more moist, and they will get, you pretty much have to double the ratio. So, alright, that's going to be long enough on this video. I'm going to go ahead and call it, and I want to say thanks for watching. If you watched all the way through, hey, appreciate it. Till next time, get your head in the clouds.